Okay, so let's do it. 3.3's homework. I'll start with number 1. I'll explain as I do it, and you guys ask me your questions. So it's a circle the expression that has the same end behavior as each polynomial. So the key here is that when I have a polynomial like this or this, look how many terms there are. This one has 2 terms, this one has 3. We could have so many terms, and it could get a little confusing. However, there's only one term that calls the shots, and that's the term with the biggest exponent. So not the one with the 2, the one with the 4. So that's it. That's what they're asking right here. They're not asking for anything more than you just being able to tell which term calls the shots. On this one, I have an exponent of 3, an exponent of 4, and an exponent of 2. It's the one with the 4 that calls the shots. That's it. That's all there is.
So we're not looking at like the main number, we're looking at like
The exponent. Yes, you guys, there's nothing more powerful in math than an exponent. All right? There could be, like, look, this is a 5x to the 4th, and this is a negative 3x to the 3rd. That x to the 3rd could have an 8 million in front of it. It still wouldn't be as powerful as something with a bigger exponent. Exponents are it. Yeah. Okay, exponents. Alrighty, now let's look. Here they want me to sketch a graph of a polynomial with the same end behavior as this guy. So let's see, our shot caller here is the negative 2x to the 6th. That's the leading term. The leading term tells me my degree. My degree here is 6. And then it also tells me my lead coefficient. These 2 things determine everything I need to know. Check it out. And a degree that's even tells me that my graph starts and ends in the same direction. It doesn't tell me which direction, but it tells me it starts and ends the same way. That means it's either up and up or it's down and down. Okay? A degree that's odd tells me that I start and end in opposite directions. So again, it doesn't tell me which direction, just that they're opposite. So I'm either down and then up, or I'm up and then down. So that's what the degree does. Now the leading coefficient it tells me which way I end. If it's positive, wait, let's do this so it turns into a nice little chart. If the leading coefficient is positive, that means that I end going up. And if the leading coefficient is negative, that means that I end going down. So this is your chart that tells you everything. If you have even and negative, this is where you're at. You see where they cross, where they overlap? This is a down and down situation. It doesn't matter what you draw on this graph as long as it's down and down. All right? You could have drawn this. You could have drawn anything as long as it's down and down. Okay? Okay. Now let's go look at some more. We're going to determine end behavior, and we're going to speak the math language while we do it. All right? The math language is, when they talk to me about x's, they're telling me left or right. An x with a negative infinity, that means left. And an x with a positive infinity means right. The f of x, b of x, d of x, whatever of x part, that's talking to me about up or down. And that's our job to figure out. So let's look at this. My shot caller in this function is the one with the biggest exponent. It's that negative x cubed. If I go back to this chart I made, a negative odd looks like this. All you got to do now is tell me, on the left side, which way am I going? On the left. It's going where? Up or down? Oh man, is this not landing?
Can you repeat? It's not hard. Can you just like, repeat it?
Yes. What's happening on the left side of this graph? Which way am I going? On the left side.
The negative infinity part? Or
Yes, okay, so the part that says as x goes to negative infinity, that means on the left side,
right.
and
Goes
then
to positive infinity.
good, it goes to positive infinity. Yeah, because it's going up.
So that's up. I was
Hi,
saying.
hi you guys, welcome.
So it's going up.
So it's going up. So you're gonna say positive infinity because that's what up is. And then it asked about, oh,
In some cases, like, can there be like positive infinity and then b of x is also positive infinity? Or is it
yes,
like
yes, yeah. If it's up, they'll both be positive infinities. If it's like, it all depends. So what you're doing is you're translating their sentence where they're asking on the left side, the graph goes, and then you decide up or down. Bye.
But is there gonna be like a drawing or like we're gonna have to draw it like on like the quiz like to like
You might have to write this whole statement yourself. Like I might say discuss the end behavior, and you might have to say as x goes to negative infinity, f of x goes to infinity. And as x goes to positive infinity, b of x goes to, okay, so this is the right side now. Let's see if you could tell me. On the right side, which way am I going?
negative
Negative infinity because it's down. Yeah.
But why does it go down? I'm confused.
The reason that it goes down is because this was a negative
Yeah.
and odd lead coefficient or lead term. And this was like, this right here, you guys, is like, and I made this and I put it on Google Classroom for you. This chart right here tells you everything. It tells you every possible combination of stuff.
It's like because it was negative, we're going down. No, but then it's positive infinity.
No. The negative I'm talking about is this negative right here.
Right. But then I just don't understand like how we know if it's negative infinity or positive.
Okay, so let's do another one. Let's go to the next one. So here we are on number 5. I first have to look at the polynomial and figure out what the biggest term, the leading term is, and that's this guy right here. Yeah, this is x to the 6th. And what I really care about is whether it's even or odd degree. The degree is even. And then I care whether it's positive or negative. And this one is positive.
So it's going to start and end in the same direction and end going up.
Right,
So
which
it would be
means
positive infinity, positive.
that's it.
Oh.
You cracked it. You just got it. Yes, but let me slow it down and explain it. So the fact that it's even and positive means that it starts and ends the same way, and it ends up, which means it starts up. So that means I'm looking at this kind of a graph, this kind of a shape. So now I got to discuss what's it doing on the left side. Well, it's going up on the left side, which means infinity. So over here, when this thing talks to me about the left side, and it's talking about the left side when x is going to negative infinity, I just write that it's going up by saying infinity. And then what's it doing on the right side? It's still going up. It's still infinity. So over here, when it talks about the right side, I still put infinity.
Okay.
That's good. I could tell it just clicked. That's awesome. I'll do more. Let's look at this guy, d of x. So much going on. I have an x to the fourth, an x to the fifth, and an x to the second, and then that's a 0. So it's this guy, yeah. This guy is odd and positive. The positive means that it ends going upward. The odd means that it starts the opposite way. So this is what it looks like. This guy is going from negative infinity. It's going down and then up. Down, up. But do check, you guys. Do check this, because there are certain books and ways and whatever where they put x to infinity on the first line and x to negative infinity on the bottom line. That would mean that they're asking you about the right side first and then the left side.
So since it's odd positive, just like make sure that I get.
Yeah.
So it starts and it ends going in opposite direction.
Yes.
But then it ends going up.
Yes.
So it starts going down.
Yes. Exactly. Exactly. Does that make sense? Okay, good. Okay, so now let's look at this last one. My biggest term, calling all the shots, is at negative 2x to the 8th. This is a negative, even. The negative means that I end down, and even means I start the same way. So it's down and down. So it's negative infinity and negative infinity. It doesn't matter left or right. But I just want you to be conscious of the fact that x to negative infinity means left, and x to positive infinity means right. And there are books and different ways that they might switch it. They might put as x goes to infinity on top and as x goes to negative infinity on the bottom. So then you would talk about the right side first and then the left side. Okay. Let's go look at number 8. Which function is a polynomial with the same degree as this guy? So what's the degree of this guy? What do you guys think? What's the degree? Degree is biggest. It's actually written on the board right there. Degree is the biggest exponent. So this is the leading term, and then more specifically, that 4 is the degree. So this guy's degree is 4. So which one of these guys' degree is 4? D. Ooh, A. Wait a minute. What's the degree of A? Because that x to the 4th is getting its butt kicked. No, not even the negative. It doesn't matter. Remember, the shock collar is the exponent. And look at that guy's exponent. That x to the 4th is insignificant in part A. It's everything in D. It's nothing in A. Next to nothing. Does that make sense? So in A, the degree is 6. Well, we want the degree to be 4. It's not 6.
Do we just want to, is it like, does negative 5x to the power of 4 not count because there's a negative 5 in front?
It doesn't count because there's an x to the 6th. He's not the biggest, baddest guy on the block this time. Yeah. It only calls the shots if it has the biggest exponent. And the only one that has it where it is calling the shots is D. Yeah. Okay. Let's go. Let's keep putting this thing to the test. Select all of the 4th degree polynomials. So we want the degree to be 4. In A, what's the degree? 4. That's the biggest exponent. B, what's the degree? 4. It's the biggest exponent. In C, what's the biggest exponent? 5. Here, this is degree 5, not 4. What about D?
4.
Yeah, D is good. And E? Yeah, that's a degree 6. It's not a degree 4. It's not. So it's just A, B, and D. Okay. Okay, this one. The one where we get to use the digits from 0 to 9 only once. We want to create 2 polynomials that follow this end behavior. Up here, 4th degree means that the biggest exponent is a 4. As long as 4 is the biggest exponent. So yeah, so D didn't count. Actually, no, sorry. E didn't count because the biggest exponent was a 6. And C didn't count because the biggest exponent was a 5. Okay, I want to make 2 polynomials that have this end behavior. Let's first understand the end behavior. The first line of this tells me what? It tells me on, what did this mean? It means on the left side, I'm going where? Up. So on the left, I'm up. And what am I doing on the right? Down. On the right side, I'm down. So this is kind of what I got going on. The information I gather from this is whether it's even or odd, negative or positive. Tell me about this guy. Is it even or odd? Look at these directions. Are they the same or are they opposite?
For the first one.
Opposite. For this one, this is the only one. No, this whole thing is one set of end behavior. It's telling me about the left side on the top line. It's telling me about the right side on the bottom line. So this looks like 2 different things. It's actually not. It's only telling me about one. It's getting freezing, right? It's getting so cold in here. My neck. Okay. This thing right here. Here. Let's highlight it. The top line talked to me about the left side. So the top line told me about that part. And the bottom line told me about the right side. So the bottom line told me about this part. But either way, it's one polynomial that's being described to me right now, one graph. Does that make sense?
Yeah.
Okay, good. Okay, so this polynomial, is it even or odd?
Odd.
It's odd because it's going in opposite directions. It's odd. So that means all my leading coefficients right here, my biggest exponent in each one of these has to be odd. So I don't know, let's make it a 9 and a 7. I just picked my 2 biggest odd numbers to make sure that the degree of my polynomials is odd. And then what else? Is it positive or negative? It is confusing. It may,
Talking about the equation or like the
this graph.
oh,
Like if you start on the left side, what's happening? What's your trajectory ultimately? Ultimately, you're ending up doing what?
it's negative because it's
Yeah.
ending up going down.
Ending up going down. So it is negative. Oh, shoot. Look at this. I didn't think this through. This can't be. These, where I put the 9 and the 7, can't be my leading term because my leading term has to be negative and those 2 are positive. So I got to go to a negative spot. Like this term is negative, you see? and give that guy the big odd exponent. And then over here, I got two options of where I can put my big odd exponent. I could have put it there, or I could have put it there. It doesn't matter. Okay, from here on out, you guys, nothing else matters. Oh man, I went from boy bands to metal bands. Who's in third period when everything I was saying? Okay, yeah. And now we're doing Metallica. All right, so nothing else matters. Put the rest whatever you want, okay? As long as you don't put any exponents bigger than 9 and 7, which, ooh, you can't use 8 in this one. As long as you make sure not to put 8 in this one, where it's going to trump that 7 and become the degree, you're fine. Make these like 1 and 2 and 3 and 4 and 5 and 6 and 8 and 0. Ooh, got myself again. Can't put the 0. You're going to have to put the 0 somewhere. Put it wherever you want. Just don't put it in front of one of the shot callers. Right here. Why can't I put the 0 in front of the x to the 7th? What's 0 times anything? 0, that means I don't even have an x to the 7th at that point. Does that make sense? So you just gotta make sure you don't put the 0 where the biggest term is.
And then did you just place, I missed it, so I was writing notes, for the 2, 4, 1, and 3, did you just like place any number?
So random. It didn't even matter.
So
Yeah.
it only has